Hey everyone, welcome to another episode of Black Guy Does Physics, where hopefully we make these physics problems much clearer. Now, if you have a physics problem or a math-based problem that you'd like me to solve, please comment below. Otherwise, I think there's a thingy that you could smash to like and subscribe, so smash it. Anyway, let's get it cracking. Today we're going to be looking at a classic freefall problem. Someone throwing something off a cliff. Don't know why they always have people throwing things off cliffs. Don't do that, kids. Now, for every problem, we do the same thing. We read. So you could read once and go right into it. I like to read twice just to give myself an idea of what's happening, just in case I don't know how to approach a problem, okay? If you're good at it, you could just go once. So here we go. A stone is thrown vertically upwards with a speed of 15.5 meters per second from the edge of a cliff 75 meters high. How much later does it reach the bottom of the cliff? Great. Now, as you can see, there's not a lot of verbiage here, aka there are not a lot of words here. So I don't think I have to do anything spectacular like make lots of relationships and all of that, okay? So now, I've read. I have to figure out what type of problem this is. So this type of problem is a freefall problem. And you're like, hey, Black Guy Does Physics, how do I know it's a freefall problem? Well, you know it's a freefall problem because something was thrown. Now, if something is thrown, dropped, kicked, flung, hurled, any one of those things, it's in free fall. As long as something is moving through the air and you're ignoring air resistance or wind resistance, and there's no parachutes or no rockets attached to it or anything, then it's in free fall, okay? Now, whenever you get these free fall problems, in later chapters, you're going to see that you're going to have two-dimensional free fall problems. This is a one-dimensional free fall problem. What I like to do is that I like to label my displacement. The reason why I like to label my displacement is that it makes my life much simpler and it doesn't allow me to get confused. So you could see here, what is the displacement? The displacement is the straight line distance from start to finish. So in this case, my displacement would be from here. Oh, why aren't you straight? To here. That would be my displacement. And as you can see, it's vertical. So I would call it y. That's my y. So that is my vertical displacement. If you have a two-dimensional one, you'll draw your x, but this is only one-dimensional. So that's my y. The second thing I want to make sure that I write down is that my acceleration here is equals to g. Okay? And my acceleration is downwards all the time, if you can't remember, because that's my acceleration due to free fall. So I write it there just to remind me, or I could just put it here automatically. A is equals to 9.81 meters per second squared. Now, for all questions, you want to write the directions where things are, because directions are very important. So I'm going to take up to be positive, down to be negative. I'm not putting left or right because the thing is only going straight up and straight down. So my up I'm going to use as positive, my down I'm going to use as negative. If that's the case, then my acceleration due to gravity would be negative because it's going down. Okay? Now once I've done that, I've gone through the little stuff I need to go through, then I go, okay, let me go through and underline things as I read. The stone is thrown vertically upward, so okay, it's going up with a speed of 15.5 meters per second. So since there's an acceleration, as we have stated in previous videos, there must be an initial velocity, a final velocity, and time. So which one of this is? This must be my initial velocity. So my initial velocity, I'll put it as v0, y, just putting it there to say that it's vertical. It's 15.5 meters per second. How do I know that it's velocity or speed? Because they told me, but it's because of the units meters per second. All right. Now I keep reading and I go from the edge of the cliff 75 meters high. So I know the cliff is 75 meters high. this thing is 75 meters high. But I also know that what I'm interested in is the displacement, because my motion equations are based on displacement. So this 75 meters is going to be giving me the displacement of the thing. So I'm going to write my y is equals to 75 meters. However, as I could see here, since displacement is a vector quantity, it's pointing down, so I have to put it as negative. So that is a negative 75 meters, 75.0 meters, just to keep my that stuff, number of significant figures. So it's negative 75 meters. Now that's where a lot of students get confused or mixed up, is that they forget that this thing, the motion equations, deals with displacement. So if you're talking about a free fall thing, I know you see the lines here, the dashed lines, but the dashed lines there are trying to confuse you to some degree. The equations of motions talk about and uses displacement, I should say. So this is what we have. You have to put that negative sign there. So now it goes, how much later does it take? So what does how much later means? How much later just simply means time. So I'm looking for t. I'm done. Okay, cool. So now, because I don't have to make any, what's it called, relationships and none being split up, it is just straight that, then what I do, if I want to solve for, let's say, anything, I need an equation. Luckily for me, I see that this is a free fall problem. And if we're talking about free fall problem, then this is a motion problem. The only thing that makes a free fall problem is because you automatically know the acceleration. So what do I do? Then I need equations. The equations that I'm going to use are these bad boys here. Why am I using these? It's due to the fact that if I'm looking at constant velocity, then it would be v is equals x over t, but I can't use constant velocity because we have an acceleration. So I have to use one of these motion equations to solve for whatever I'm looking for here. So how do I go about solving for these equations? Well, I replicate the same thing every single time. I know some of you are thinking, oh, it's that one, and yes, I want to do that. Cool, you could do that. If you see it off rip, go get it. Go for it. But I like to, keep it standard so that I could do the same thing every single time. I don't want to know how to solve this one only. I want to solve every single motion problem the same way every single time. That's the hack. So here we go. So we're looking for time. So automatically, this equation cannot use, this equation cannot use. But why can't they be used? Because there's no time in it. So now I'm only left with 2. So how do I figure out which one it is? I simply go through and just, match up. So I'm looking for time, which is this thing. Do I have A? Yes, I have A. Do I have V0? Yes, I have V0. Do I have V? No. A lot of students, a lot of people actually, think that the speed here would be 0 because, oh, it stopped. No. Get it out your heads. Things don't hit with 0 speed. They can't hit with 0 speed. If that's the case, you should run into a wall and see what speed you hit with the wall, okay? It's not going to be fun. Kids, don't do that. All right, so this one you would need V. So you're missing the final velocity, the speed that it hits the water with. So we go again. So we check this one again. Do we have X? In this case, X is your Y. Yes, because it's just your displacement. This thing is 0 because you're starting from 0. This one you have. This is what you're looking for. This is what you're looking for. And this you have. So ding, 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 ding. This is the one I'm going to use. So I'm going to use my Y is equals to V0Y t plus half a t squared. So here we have what is considered to be a quadratic equation. Now I'm pretty sure I did a video on quadratic equation. If it's not, just leave a comment in there and I'll make one. How do you know that this is a quadratic equation? You see this t, it has a square. Then you look over here, you see another t, it doesn't have a square, it's like a single term. And then you see something here just chilling by itself. So whenever you see any equation with a squared term, something being squared, a thing where the same thing is not being squared, and then you just have some junk just chilling, it's a quadratic equation. So this is a quadratic equation. It's one of the few quadratic equations you'll run into physics with. So let me write quadratic here. So if you want to solve a quadratic equation, then what you need to do is first you want to punch in these numbers to make your life easier. So this is minus 75. Now, I'm not going to put the units. Why? Because my units are already in SI unit form. And whenever units are in SI units form, I don't have to carry them through because at the end, the units will work out to be SI unit form. And the units just make it cumbersome. 75 is equal to my V0y, which is 15.5 t plus half a t squared, which I think that would be minus 4.9 t squared. Cool. First thing you want to do after you plug those numbers in, you want to shift this over. So you want to set this thing to 0. So I'm going to put this as 0, and I'm just going to move this over somewhere here. So this becomes 15.5 t minus 5.9 t squared plus 75. And then the rest is you just follow the instructions. So in order for you to solve a quadratic, you need to have it, the things, you have to know what A is, B is, and C is, because there's a format that is set up, which is minus B is equals to the square root of B squared minus 4AC over 2A. So you have to know what the things A is and what B is and what C is. So A is the stuff that is attached to the t squared, to the square term. That's your A. B is the stuff that is attached to the single term, in this case t. And C is the stuff that is attached to nothing, just chilling. That's the constant. That's why it's ABC. Cool. So now if I want to find t, then t should be equal to minus b plus or minus the square root of b squared minus 4ac all over 2a. Now that would be, what is that, minus 15.5 plus or minus the square root of 15 squared minus 4a, oh lord, 4 what's a? Minus 4.9 times 75 all over 2 times minus 4.9. Now, I'm definitely not going to work this out. You could punch that in your calculators and solve, but you should end up with 2 times because there's a plus and a minus there. Usually you want to take the positive time. Usually. In this case, you'll have a positive time, you'll have a negative time. In the cases where you have two positive times, then you'd have to decipher which one it is. But if you have one positive time, one negative time, it's easy to decipher. Take the positive one. Why? Because time can't be negative. And with that, you're done solving that part. Check mark. Let's go. W's. Now, part B. What is its speed just before hitting? So now you're like, oh my God, I need to go find the speed. This is part B. I need to go find the final speed, V. I'm going to put Vy. So we could replicate or write down the things that we have here. I'm going to just copy here and paste here. So we still have these things, and now we have the added benefits of solving for the time. I know what a time is. So once again, I don't have to make any relationships or anything, so I'm good. So the question now is, how do I find Vy? Well, if you want to solve anything or you want to find anything, then all you have to do is that you have to, what would I say here? Use an equation. So since this is motion, which is free fall is motion, I need the sets of equation here. And we already established that it's a constant acceleration. It's not constant velocity because we know that it's accelerating. So we can't use v equals x over t. So it must be one of these. So all I go do is just repeat the same thing I did before. Remember, we're trying to hack this thing out, man. So I want to do one thing all the time. So what do? The same thing I did before. So I'm looking for Vy. So this is the thing I'm looking for, the final. Do I have the initial? Yes. Do I have the acceleration? Yes. Do I have the time? I just solved for the time. Sweet. So I could use this first one here. What if I didn't have the time? Then I could even use this one. In this particular case, you could use any one of these. So I don't even want to use the one with the time. I'm going to be fancy. I'm going to say this. I'm looking for this. I know this. I know this. I know this. Oh, I just said I know 2. Yes, you definitely know the 2. And I know the x because this is 0. Okay, great. So I could use any one of these would work. This would work. This would work. This would work. But since I didn't solve for the time, I didn't give you a numerical value for the time. I'm going to use the one that doesn't have the time. You could use the one that has the time. Any one of them works, okay? So let's go here. I would definitely not use the second one though because it looks like it's kind of tedious. So v squared should be equal to v0 squared. I'm going to put y's there just for practice. 2ay. Good. Therefore, vy should be equal to the square root of v0y squared plus 2ay. And you could substitute in these numbers and solve. That you could do. Great. Ta-da! W's. We love W's. What is the total distance? Now, this is where students lose their mind because they don't understand the concept of the total distance here. What is the total distance? It's from here up all the way down. So I already know from here to here. Therefore, I need to know what is this to this. So I can break this motion down. So let me put this in blue and let's make it a little bit bigger. I could say the thing goes up to there and to there. So these two blue lines are the same distance. So if I find this distance, I could figure out what this distance is just by multiplying it by the original one by 2. Because the distance it travels up to the top here must be the same distance it travels down back to here. It has to. That's just common sense. Now, what is special about here? About that point at top? I should have copied this thing here, but whatever. It's at the top here. What's the thing that's special here? At the top here, the thing that is special is that the Vy is equal to 0. It stops because it's at its maximum height. The vertical speed there isn't no more. And this is only vertical. It's not going left or right. So the Vy there is 0. So now I know a new term or a new thing that it's 0 here. Well, I am going to call these things, let me label them. I'm going to call this y1 and call this y2. Oh, I don't like those colors. Let's just put it in a different color. Blue. y1 and y1 and y2. Good. So, the total distance, we're looking for part C. The total distance would be the total distance. The total distance, let's call it D, would be equals to y1 plus y2 plus y. And we're using all positive values here. This is distance, so the direction doesn't matter. So we know that y1 should be equals to y2. We know that. So we just have to find y1, right? We just have to find y1. So that's what we're really looking for here. What is y1? But the thing, we know that this stuff is there. One second. We know that this stuff is there. We still have that stuff, right? But this is gone. It's no longer there because we're just looking for y. This is gone because that's not the time. We know the initial on that, but our new thing that we know is that the Vy should be equal to 0. Why? Because it's at the max height. So let me run that by you again. Here, what we're saying is that we're looking from here to here. That's my new thing. Before we were looking from here to here. Now I'm not doing that no more. I'm looking from here to here. So the time that I found before is not the time that we're going to be using. It's definitely not. So this is a new thingy. Okay. So what is the new information I have? My Vy is equal to 0. So if that's the case, and I want to solve for my y, then once again, how do I solve for these things? How do I solve for these things? I must have an equation. Since this is a constant acceleration thing, I must use these constant acceleration formulas. And you could see all we're doing is repeating the same scenario that we did before. So we're looking for y, so I need something with y in it, or some displacement. So automatically this is gone, this is gone. So then I check. I'm looking for y, yes, this is 0. Yes, I have my v0y. Do I have my t? No. I have a, don't have t. So I need t here. Then we run the same scenario here. Do I have my vy? Yes. Do I have my v0y? Yes. Do I have my a? Yes. And I'm looking for x. This is 0. So I'm good to go. This one works. Ting, 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 ting. So we have v squared y is equals to v0 squared y plus 2ay. And then I could shift this over. If you want, I could just solve for y1. Let's put y1 here. y1 should be equals to vy squared minus v0y squared all over 2a. And once again, please remember that this goes to 0. So you'll end up with that. And once you work it out, you'll end up with your answer. You could finish that out for yourselves. And that's it. Look at that. Let's put a check mark here. Alrighty. Hopefully I made this a little bit easier for you to understand. Hey, once again, like, subscribe. Hey, that thingy. Press it. You know you want to press it. Like, subscribe. Let me know, comment. Let me know how, if anything, I could do better. Anything you want to get solved, so on and so forth. And kids, remember, don't be a moo-moo.